Welcome to Hackitected Playground. This is a new episode and it's very special. There's a summer out there and we all are enjoying our time. I'm still doing videos, no worries. I'm just trying to focus on the quality. I was doing lots of in-person events and lots of conferences, so didn't have enough time to prepare for you some good content. So now is the time to present you a new thing and something that you haven't seen before. So this episode is about serverless top 10 issues in security, and let's start with that. Hello there, we'll talk about the top 10 serverless security issues in cloud. I will be focusing on AWS and I hope that you will enjoy it because that will be very special, I will say, episode and experience for you today because I will try to even gamify it for you. So, what are the major problems known in Azure? And I'll just select a few of them. There are many others. I just want to say that cloud is not designed to be super secure for you. There is a shared responsibility model which says that part of the security is you and it's your responsibility to make sure that everything is smooth and clean and is secured. And AWS and Azure, they are taking care of their services that they are secure enough by design, but also the code and design that you do on your side is your responsibility. So when you look at that, there is Chaos DB for Azure Cosmos DB takeover vulnerability, or Azure issues are not adequately fixed for months. So this is a very common issue. If you look at this is from June 2022, and you can wait months before the vulnerabilities will be fixed, and you need to count with that because they manage your infrastructure, they manage your services, and you need to build layered security and different countermeasures for different purposes in the cloud environment. So you need to build layered security. Or Azure Escape, this is a very known problem with the cross-account container takeover in Azure container instances. I remember that it was like a huge thing, or privilege escalation in Azure, where you basically get elevated privileges and you can go to another tenants. That was a very common problem in Azure. But Azure is not alone. If you look at GCP or AWS, there are always some issues. Good thing is that the cloud providers are working on securing it. So when you will look at Azure Glue issue or SageMaker Jupyter Notebook, there was lots of issues with SageMaker takeover, or there was cloud trail injection where you can inject the trail name with some code, and this code can be executed in your SIEM or monitoring solutions. Or there was STS get caller identity with the Glue job runner session takeover. That are so many things that happen, and I will say that Azure is having more issues than AWS, but it doesn't mean that it's flawless. So when we look on the Oracle Security Report, a very old vulnerability known Superglue. So if you like glue, don't eat it. This is just Superglue. So the Superglue resource or AWS attacker account can use a weak role to elevate its privileges to admin role. And this admin role can assume the role for IAM glue role in target account, which means that you can get access to the target account for another customer where the role has a permissions for other AWS services or another type account. And this is very known issue, and it was fixed very fast by AWS, but I really need to say that this was very big concern and very big thing which happens I would say a year or two ago. And we will be talking about serverless top 10, so I really want to explore with you all the possibilities and explain what actually serverless means and what are the common attacks on it. And I did updated version for 2023 for you just to have a fun. So for those who don't know what is serverless, and I believe that everyone here knows what is serverless, but just small repetition. So if we will look at that, serverless is for running code and managing data and integrating applications all without managing servers. If you will look at that, there are no servers from your perspective, but there are servers from the cloud perspective. That means that AWS or Azure, they manage the services for you and they virtualize it on the application level. So there is a level of abstraction. And so that it doesn't mean that there are no servers at all, but from your perspective, there are no servers. But from the management perspective and from the data center perspective, there are servers running. For example, Azure is using Firecracker for virtualization of Lambda. So that's something that runs on the background. And we will talk about that a lot. So serverless technologies feature automatic scaling, built-in high availability, and pay-for-use billing model to increase agility and optimize cost. And that's what serverless means. You pay for what you run. Interesting thing that it can lead to some very interesting attacks. So what are the common web application patterns? If you look at that, for example, there is very huge usage of API gateway and Cognito for AWS for authentication, or Lambda calls to DynamoDB or NoSQL, or DynamoDB is a NoSQL implementation, or a fan-out notification system. So even the firehose, streaming services for analysis, or operation serverless monolithic with CloudWatch. So if you will look at the users, for example, for the users here, it's like, hey, the website bucket, that's something they visit with the static content. They log in through Cognito. The API call another Lambda, and Lambda is calling the NoSQL database. And there's a fan-out Lambda, which is sending notifications through Event Bridge, which is Event Bus, to Firehose, which is a streaming service, to another S3 bucket, where the administrators are looking through Athena, which is SQL-like service for S3 bucket queries, on what is happening in the logs or what is happening with the analytics. And there can be another operator looking at the CloudWatch, which is also serverless service for logging, and watch the alarms and dashboards that are run on AWS. Another interesting application pattern can be image recognition. And I'm taking that from AWS examples and even from the documentation, so it's not my invention. So if you look at the client can hit the CloudFront, and CloudFront is connected to API Gateway. API Gateway is a typical serverless service connected with AWS Lambda, which is function-based service. And this AWS Lambda can use Amazon recognition, and this can be used for recognizing images and recognizing whenever you like, for image analysis in this case. So in AWS Secret Manager, you can have secrets that Lambda is using, so they are not stored directly in the code, and it can store the data in Amazon S3. So this is a typical components that you can use, for example, for image recognition in the serverless world. And there are some flaws that we will talk about very soon. And there's another pattern with serverless CI/CD, so you can have your Git repository whenever it is GitHub or GitLab or whenever you use. You can go with a CloudWatch event, and this event-based architecture can execute the source with the application built with AWS code build, and then you can deploy it with AWS code deploy and any other solutions that you want. And you can have even artifact store. I have here artifact store with the S3 bucket, but now there is a AWS code artifact that you can use for storing your artifacts. And that's something very interesting, and that's something that I recommend you to explore. And if you will go to another deployments that you can use, for example, Unicorn and GNOME, that's basically blue-green deployment. You will have serverless roles, Unicorn stack, GNOME stack, and sample application running in Lambda. So you can have your Canary deployments, you can have your blue-green deployments, even with serverless. So when we look at another serverless pattern, for example, with the SageMaker AI-driven pattern, so it trains user predictions, and basically there are ML batches that are stored in S3. This AWS Lambda pull the data from the S3 bucket, basically some JSON data, and upload them in Elastic Cache for Redis. This is population of the cache, and then the Lambda is trying to get the data, or it's getting the data from the cache using the ID to provide the recommendations to the user, and the user can consume these recommendations through the API, which is a direct endpoint where user communicates with it. So let's play a short game together. I think that this will be pretty fun because, and also I have some short question on you. Just try to guess which game design I use for the cards and put it in the comments. Just let me know. Put it in the comments which game design I'm using for this serverless game that we'll play together. So let's start with the game itself. So we'll talk about the serverless top 10. First problem that appears in common serverless application is an event injection. Typical attacks like cross-site scripting, remote code execution, or OSS command injection are still valid for Lambda or any other function because injection can lead to leakage of the environment variables or the containment of the runtime if you write bad code. So it's not secure by default. It is secure by default in some extent, like the runtime provided by you is secure, the permissions are there for you, but you need to configure them. So if you mess up your code with remote code execution, I will show you very soon what can happen and how serious impact you can have on your application. Then broken authentication is another point, like exposing unauthenticated entry point or some visible endpoint point like S3 bucket or public access for Kubernetes, or unrestricted access to AWS EKS. That's also a big problem, like public clusters when you don't want to have the public clusters, or public ECRs that you do not want to have public ECRs. And for that, you can have like CNAP or cloud posture management, or whatever you will call it, like whenever you like to call these things today. But for any purpose, you really need to have this broken authentication protection. So sensitive data exposure is like, there are various mechanisms how to get and dump the secrets containing the API private keys, passwords, environment variables, or data dumping from the S3 and Lambda, or even the DynamoDB are very common attacks. So also the anonymous request or request to access to AKS namespaces. So there are lots of interesting things that you can do with the sensitive data exposure. Even your GitHub token can be easily, or your API token or AWS access keys, even when you delete them from your GitHub repo, they will be still in the commit history, and there are like scanners like GitLeaks, Trufflehawk, and others. They can scan the history and they can get there and they can read the credentials. So you need to rotate them. And for that, AWS Health Dashboard, they even have notification system. So please go and configure it. So another point is infrastructure as code injection. So injected infrastructure or black infrastructure, whatever you will call it, or malicious infrastructure. This infrastructure can be injected through Terraform or CloudFormation, any other language are you using. For example, injecting new code in the bucket, or injecting new code in the dependency of your Terraform with the malicious modules. Another point is broken access control. It's very, very common problem with the flow control. Lack of semantic reasoning in IAM can lead to privilege escalation. So you don't know what is the flow between the role, and it can lead to elevation of privilege, basically to broken authentication. Especially with offensive infrastructure as code, manipulating application flow can lead and help the attacker to change the application logic by bypassing access controls, elevating user privileges, or even cause the denial of service attacks. And that's something very serious to concern. Also, think about that. If you are elevating user privileges or anything like that, it's very simple today. Even Metasploit has newish, oldish library called Pacu, or tool called Pacu, and there are already modules for that, so you don't need to be ninja to do it. Another point is the cloud security misconfiguration. Misconfiguration can lead to sensitive information leakage, money loss, denial of service, or severe case of unauthorized access to the cloud resources. A problem is missing implementation of continuous testing, auditing, and security monitoring in your serverless infrastructure, chain attacks, and function manipulation. And for that, please sign your serverless functions. Because if somebody manipulates your code, how you will discover that? How you will discover that somebody changed your code? Only by signing your lambdas and knowing that somebody just changed the code and there is a problem with the signature. Another big problem is called denial of wallet. Denial of wallet is a specific attack that targets serverless users, and it basically goes to increase build spend on the cloud provider. So they want you financially bleed and financially harm you because you have improper budget setup. You didn't set up your budget restrictions. You do not have your basic alarms in place. You do not have reserved instances, or you do not have any notifications if your budget crosses specific lines. And that's the first thing that you should do in any cloud environment. So insecure deserialization, because in cloud there is lots of JSON, there is lots of object serialization and deserialization. So common Python and Node.js frameworks allow deserialization attacks, and Python and Node.js are very favorite choice of serverless implementation. So insecure deserialization usually results in running arbitrary code that could eventually lead to the data leakage, in severe cases even the resource and account control, because they can get the credentials which are hidden behind your Lambdas in the runtime. And Lambdas, they have specific permissions. So using components with known vulnerabilities, so supply chain OS security, testing OS's vulnerabilities and dependency security testing is underestimated, and you should take care that you have continuous monitoring of serverless functions and their third-party dependencies, or manage. And you also need to manage something called software bill of materials. Even like there's KBOM, like Kubernetes bill of materials. All of these things you need to store somewhere else, not in the same account, maybe some another S3 bucket or a third-party platform, or if you want in your DynamoDB. That will be great, and don't forget to do that. So insufficient logging and monitoring is still the case for the cloud applications which do not implement the proper auditing mechanism and rely solely on their service provider probably have insufficient means of security monitoring and auditing. So what I'm seeing often, there is no code profiling. There is no application logging in place because people think that AWS will do it for them. Or there is lack of annotation in the code to help you with the application tracing. So people usually forget to use even the X-ray or any other tracing mechanism to know how your code behaves, to track the latency between different calls. And in serverless world, that's a super necessary thing to do. So we will move to event injection. That's one of the concerns that I want to introduce today. And that's, like, I would say, booming topic that I hope that you never see anything like that before. Think about that you have AWS WAF, you have API gateway, you have vulnerable Lambda that you messed up, and function role that can call S3 bucket or EC2 instance. And I will show you how crazy you can go with the remote code execution with Lambda when something will go very, very wrong. So AWS WAF usually inspected till this year only first 8 kilobytes. So if you create some padding with 8 kilobytes, you can get rid of the inspection on the WAF side. Nowadays, it can be up to 64 kilobytes, which is much more, but still you can play with the padding a little bit. And if you mess up the request body and you can create proper padding, and your Lambda will have vulnerability, it's too many conditions, but it's still feasible. You can use the function role to get access to specific resources and get the AWS Lambda credentials that are running on the background in the environment. And usually you have the STS token where the minimum STS token lasts for 15 minutes. If you will lose this token, you can cause Lambda loop, but it's also limited to by 15 minutes. And there are other attacks that can cause like Lambda running longer. That means you pay more. So if you do not have maximum execution time set up, you can mess up too. That's something that you need to keep in your mind in the first place. And now it's time to have a proper fun with the remote code execution or event injection in Lambda. I have prepared the Lambda API. So I'm using API gateway connected to Lambda. I will show you here. Here is my Lambda with the vulnerable code. The code is vulnerable by default. Just to show you what can be the problem, I will go to functions and I have this remote code execution Lambda, which, if I will show you function overview, it's called from API gateway. So imagine that you have API gateway, normal situation, and vulnerable Lambda on event injection. And this is, like I will say it again, intentionally vulnerable code to show you what can happen if you do not write proper and clean code in Lambda, and you have lots of services from AWS to utilize for your scanning. So that's important to keep in your mind. I will go to API console and I will show you one of the methods. So you see here that if I will go to post and I will run test, I can request the body against this Lambda. And you see here that I have key with export, ls, and pwd. So that are the Linux commands execution. And I can show you what is behind that. What is hidden on the runtime of the Lambda. So when I will run test, and then it starts to be interesting because it will show me the environment variables running in the Firecracker or on the background of the Lambda itself. And there is AWS access key ID, and there is even the secret key ID. I will show you. AWS secret access key ID. So if you will be able to get these credentials through a remote code execution, you will be able to access to the same services that your Lambda has access, and this is pretty problematic. I think that that can be something that can, cause a big harm. And if you will go to Lambda itself, and I will run a test against this one, it will show you all the possible options that you have here for the export. So when you will run export through, or like server-side injection on Lambda, or whenever you will call it, so, or whenever type of attack you will use, or out-of-bound attacks that you will use, you will get the region, you will get the Python version running there, you will get the credentials, you will get the X-ray content mixing. Lots of these things can be used to attack your account if you write vulnerable Lambda. Think about that, and think about that twice before you will start to review your code. And that's something, because the events can flow through the event bridge, and you can have injection in the event bridge and it will flow through whole infrastructure, then hit your Lambda if you do not have proper input validation, if you do not have proper output validation. You can end up in the situation that your account will be exfiltrated, or it will be attacked, completely takeovered, and you will cry because you will have hard time to find the attacker, because they will be using Lambda runtime to get in your account. Another not very known problem in serverless top 10 are denial of vault attacks. These denial of vault attacks, in addition to the traditional web-based distributed DOS attacks or flood attacks, or whatever you will call it, it basically focus on something else, because the typical DOS wants to crash your application and cause unavailability of the application. Denial of vault attacks specifically target the serverless apps, because you pay for what you run, so pay as you go. But denial of vault seeks to cause the victim the financial loss due to lack of billing alarms or FinOps practices. FinOps means financial operations, where you have Lambdas, automatic solutions like alerting systems, like even disabling services in the specific time where you don't need them, running them only when you need them, or scaling to the maximum amount of instances and serving the maximum amount of customers, or creating queues or other things. Because then if you do not have proper safeguards, denial of vault exploits are similar to denial of service, and they are carried to intent to disrupt your business. And in this case, it means from the financial perspective. So if you do not set up properly your budgets, your billing alarms, you have a huge problem, because somebody can cause your Lambdas or anything run longer than you expected, and your bill will be very surprising. When we are talking about the budgets, I want to show you something super important, and that's AWS documentation around managing the budgets and your cost. Basically, there are a few budget types that you can utilize. It's a cost budget, where you plan how much you want to spend on specific service. Usage budget, where you can say, I want to use it for one or more services. Reserve instances utilization budget, so you can define the utilization threshold and receive alerts on your reserved instances. You can have even coverage budget, which are coverage thresholds, and receive alert when you have the number of instances, for instance hours, that are covered by reserved instances that fall behind or below this threshold. Then you have saving plans utilizations, so utilization threshold for your savings plan, and then for the coverage budget. So you can define the coverage threshold and receive the alerts when you have the savings plan eligible. So you have various ways how you can even do it, and there are even best practices for AWS budget. So using managed policies, using the auto scaling, and with some policies. Best practices for the setting budgets, understanding the budget, what is the frequency. There's even video from AWS, and all of these things that you can even run, or budget reports. If you want to understand the budget reports, there is a creating budget report and the report frequency. This is the thing that you should go and do right now. Another problems that I want to raise around like denial of vault attacks or enumeration services is Node.js event loop for timing attack. This is a very common attack on authentication Lambdas, because if you are comparing two tokens, you need to implement the code in the way that comparison of two different strings with the two different lengths will last every time in the same time, because if it lasts for a different time, based on the evaluation time, you can run an enumeration attacks. So that's also like a side topic for this event loop timing attacks, but you can even send very long tokens, and because it will compare it like byte by byte or word by word or letter by letter, and it will like last for a very long time, that means that you will cause Lambda running for a longer time than the user expected. For example, they will know that the maximum password size is, I don't know, 8 characters, but you can cause it like, I don't know, 5 megabytes or whatever. You can craft your own payload, and it will cause, because it will compare the strings together for like a longer run than you wanted. And here, when you see on this card a Lambda looping attack, it can be performed each time when the input impacts the processing time. And attackers can use these techniques to making small cumulative delays, which you will pay and you will run. And I borrowed this code from Sneak Learn because this is a very good example of looping attacks and causing problems. You see here that on the second remediation, like sample code, you see that the time when you are comparing two different strings, you are not using like triple equal, but you are using XOR and another operations are lasting for the static time of the period of the time, then it is much easier for you to protect yourself. So we'll move forward in our game, like preventing the denial of wallet attacks. You need to prepare the CloudWatch, billing alarms, limit Lambda timeouts for necessary minimum, prepare short-living IAM roles, which are lasting only for the time of the deployment if you are using CI/CD. Disable running instances when they are not needed. Prepare for you the FinOps practices and automation and tooling for you. There is a Kubectl, Finala, Greenbot, whenever you like, Lambda power tuning. So lots of different tools that you can use as protection for this card. And GitOps helps you to reduce the roles needed to manipulate your resources. Use your Git or GitHub or any Git source control as a source of the truth. This is the protection card that you can play against the attack. Another great card is how you can secure your Lambdas. And this is an example from AWS documentation from the antipatters. You can have infinite looping of the Lambda. Like you have an event, you put the object about this event to S3 bucket, and then Lambda is again executed because you put a new event. And this event is again putting new object in the bucket. And it repeats till infinite, and your Lambda build is flying to the skies. So AWS Signer, and this is not only protection against this pattern, this is just bad example how you can mess up by yourself by bad design. So security implication is not caused only by vulnerabilities, it's also caused by the design itself. So AWS Signer can use you can use for help on Lambda modification. You can use Sneak, Whitesource, or any other Lambda OSS scanning that will help you to understand your code and third-party dependencies. Or you can use AWS Code Guru for code reviews, and even the Code Guru helps you to run the profiling, and the profiling will tell you how you can improve the runtime of your code by loading the libraries in the proper time and using the methods in the proper order. Another interesting point is backdooring exploitation of ECR, which is related to this serverless top 10. So compromised credentials can lead to listing the ECRs. And if you get these credentials, you can pull your image from the ECR and use Cloud Container Attack tool that I was showing in one of the videos. And you can push this improved image back to the repository without the owner even noticing that. So, and this is a real life example. So you should, and this is another card that you can play against this malicious attacks. So you can use your GitOps for images. You can sign images. You should use Kyverno or cosign or whenever. Kyverno for policies, cosign for signing. You can scan your images. You should limit your IAM for CI, and you should have proper execution role. So, and even you should restrict developers against the put image and initiate the layer upload. So another problem with the Lambda code S3 or DynamoDB dumping is when you will look at that is like you can use Amazon DynamoDB accelerator called sorted DAX, which provides an encryption at the rest. And if you will look at you can even use IAM credentials or IAM permissions to say in which tables or which parts of the tables specific user has access rights. And you see that ultimate dumper, I'm using Paku as example, but you can enumerate all the buckets in the account that has access to your resources and then prompt and download all the files with Paku. Or you can enumerate your DynamoDBs and with the goal of finding sensitive information. And there is a like very simple check for sensitive information dump. So you just dump it with the Paku, which is a tool for penetration testing of AWS. So sensitive data can be flagged and downloaded. So you need to say that only the users who created specific entries, they should have access to their data. So you should even use the TTL, like time to live per item timestamp and IAM conditions. Or create, read, update, and delete for all the operations in Lambda. And here we have something very interesting that I need to say that I really like a lot. And it's Lambda code S3 DynamoDB dumping. You can even use, and this another protection like AWS CloudFormation Guard that can help you understand your CloudFormation. And I will show you a very short example with Paku, where you can see all the modules that we have here for Paku. And I will say, okay, run Lambda enum help, and it will tell me, okay, you can dump all the versions of Lambda with the region and checking the source. So I will say, okay, run Lambda enum with all versions, and please for also the regions, I will specify the region, and I can even use the check source to download the code. And I was saying, hey, let's run enumeration of all the Lambdas, and I'll see which Lambdas are also there. And if I want, and I can even download the code of the Lambdas itself if I have permissions for that. And that can be pretty neat and pretty nasty if you will see what can happen with that. And it is very simple. So you should use AWS Trusted Advisor, AWS Macie, AWS config roles, and transport over HTTPS all the time where possible. I'm talking about HTTPS on S3 buckets mainly. And there's another option. What you can do is using Security Hub with the AIC scanners, infrastructure as code scanners. You can even send the data through the language for Security Hub. They have their own vulnerability description language. And you can also use SSA or client encryption for S3 buckets. And IAM restrictions and ACL for the objects, but ACL is becoming deprecated, so IAM restrictions are the best way how to do it. And guard duty for S3 protection also for the S3 data events. So we need to enable the S3 data events for this specific purpose. And there is another really good and interesting thing. It's offensive infrastructure as code. This library is called Offensive Terraform. It contains lots of nasty things. You can download publicly exposed snapshots for inspection. You can have S3 subdomain takeover. You can spin up the Kali instance. You can create new new system, new security groups in the account. There are lots of interesting things that you can do with offensive infrastructure as code with the malicious modules and malicious dependencies. So defense for the DevSecOps is GitOps with ISC scanning, policy as a code, and SAST, static application security testing applied on infrastructure and also on the application itself, and also on the third-party scanning or third-party libraries. Atlantis, Flux, and OPA, Open Policy Agent, can help you a lot. Chekhov and Terraform vending machine are the necessary things. Terraform vending machine today is differently named is Account Factory. So Chekhov with the Account Factory is the best way what you can do. There is another attack. Now we will look at the attack card. There's a CloudFormation injection, and you can use template URL in the parameter with a create stack API call, and you can push in the 1 second delay new CloudFormation template and inject your own data, for example, new administrative user. And you can inject Lambda with a template, inject new admin role into CloudFormation bucket, which is super dangerous. And there's another attack card that you can play is Terraform attack, and there are like modules for copying the snapshot, creating Kali Linux, opening security groups, adding new cross-account trust, creating persistent user or Lambda exfiltration. And all of that is fully available on the internet. I just do not want to share the resources for that because I'm sure that you are very clever. And this is only for the research purposes. So you shouldn't use it to test your account or exfiltrate your account. This is only for research purposes to understand where can be some flaws. So, and there is a finding from Reno Security Labs. They found the CloudFormation resource injection where you have something in your Lambda, but there's like some precondition that I need to say. You have leaked credentials and you have access to the victim account. You can create a Lambda modifier with the S3 object notifications every time when they upload new CloudFormation template. You can download the CloudFormation template and upload the modification with the delay that I was saying that in the previous slide or in the previous experience. And you can do it even with the Cloud Development Kit, like with the CDK, because the AWS CDK synthesizes CloudFormation on the background. So all of these things can happen even when you are using CDK. And this is very dangerous. That's why even you need to restrict the permissions. You need to scan your code. You need to even like hashes of your code. You need to have also drift detection. And this year there is a new feature for CloudFormation which is called drift detection, and you can use it to identify the drifts in your code. And when we are talking about the drift detection, what drift can mean? That means the manual unauthorized changes in infrastructure as code state, microservices misbehavior, changing the API or via API, other provisioners, or out-of-state executed infrastructure as code. And drift detection can help you detect malicious infrastructure and misconfigurations. So not only your own mistakes, but also somebody operating in your account. So what you can do with that, you need to test your Terraform, CloudFormation, and ARM on security issues and known problems. You need to even lint it. So do not load any external templates from untrusted resources. 100%. If you do that, maybe it's time to search for a new career because that's very dangerous behavior. An example to link is driftctl from Snyk. This is open source that you can try. Or Terraform AWS ClickOps Notify. This is open source Terraform only module which executes common console actions. So if you will look at the card for the remove ClickOps, scans the cloud and map the infrastructure as code to resources, analyze the diff, ignore resources if you want, and different output formats. That's what you can do with the driftctl. So it analyzes the code, analyzes your state, and it will tell you what's the difference. So it can even take the data from your cloud. It can create a metadata file and it can compare it with your state file, and it can say, hey, there is something problematic. There's something that doesn't work. And that's something that you should practice day by day, and you can even have it in your CI/CD. And I'm thinking that I will create a specific or special episode just dedicated to the drift detection. And here are some references for today, because not everything is just from my head. Lots of these things are, but I really want to show you that you have some reading to do and there's some homework for you. So thank you for watching and see you next time. And before we'll end up today's session completely, I still have one question. What is the game design on the cards? From which game? Please put it in the comments, and thank you for staying till the very last end.